Hi class! So, it's me again, Engineer John Ray Pacturanan. So, this time, ang pag-uusapan na natin ngayon ay ang highlight ng chapter natin which is nga the double integration method. So, this video clip has no example yet. So, yun ay nasa next videos na. However, ano ba yung pag-uusapan natin dito sa video ito? So, pag-uusapan natin yung mathematical process kung paano natin madederive yung process ng double integration method, yung mga sign conventions niya, at the same time yung boundary conditions. Kasi nga kung maalala nyo, sa review of integration, para mahanap yung arbitrary constant, kailangan natin ng mga boundary conditions. And lastly, of course, the procedure for analysis. Okay? Kasi kung maglilagay pa ako ng isang example, baka maging sobrang haba nitong video na to. So, gayon man, subukan na natin class na i-discuss siya ngayon. So, sige, double integration method. So, ang unang process is the differential equation of the elastic curve. Curve yan, takpan lang ng mukha ko. So, dito, i-discuss natin kung saan nanggaling yung process ng double integration. So, sabi dito, from the previous discussion, which is the elastic beam theory, so it is defined as 1 over rho equals m over ei, where rho is the radius of curvature. However, class, from differential calculus, di ba? Sa differential calculus natin, the formula for the curvature of the curve, so that is k, is equal to the reciprocal of the radius of curvature. So, kung maalala nyo to, and that is equal to y double prime, where y prime is the second derivative, all over 1 plus y prime squared raised to 3 halves. So, this is class the formula for the curvature, which is 1 over rho. So, of course, ang naiisip nyo is isa-substitute natin itong 1 over rho dito. So, therefore, magiging y double prime, the quantity 1 plus y prime squared raised to 3 half equals m over ei. So, di ba, napakasimple lang naman yan. And that will be our equation 1. So, next tayo, usually, the slope of the elastic curve class, no? So, usually, the slope of the elastic curve is very small. So, yung slope natin is defined from calculus is y prime. Thus, we assume that sobrang liit na nga niya class, tapos in-square mo pa. Eh, di ba, normally, ang mga maliliit class na value, pag in-square mo, is automatic, nagiging approximately equal to 0. So, yun yung assumption natin dito. So, usually, due to the fact na sobrang liit ng y prime, kapag in-square mo siya, almost 0 siya. So, kapag sinubstitute nyo siya class sa equation 1, so yun, magiging 0. So, therefore, ang magiging ending dito sa baba, 1 na lang siya kasi 1 plus 0 is 1, 1 raised to 3 half is still 1. So, by cross multiplication, ei y prime is equal to m. So, ibig sabihin, it means that the moment function is equal to the second derivative of the equation of elastic curve multiplied by flexural rigidity ei. So, ito kasing y double prime is the second derivative class of the what? Of the elastic curve. So, yung y is yung equation ko. Kasi parang equation lang siya class na y is equal to the function of x. Ganun lang yun. So, therefore, the second derivative of that function is the moment function. Eh, di ba sa chapter 4, we already discussed kung paano natin na-derive yung shear and moment function. So, it means pala class, no, yung moment function na yun, second derivative pa. And since second derivative siya, ang gagawin nyo, take the integral of the moment function in order to obtain the slope function. So, that is y prime or simply theta. So, ito, ang baka magkalituhan, parehas lang naman yan. So, ei y prime plus or ei theta is unang beses i-integrate mo yung moment function. So, i-integrate mo siya. And however, since this is still in the slope, kailangan natin mahanap is yung mismong y, take the integral of the slope function in order to obtain the function of elastic curve, which is y or delta. So, parehas nga din to. So, ei y or ei delta equals the integral of itong naunang na integral nyo. So, halimbawa, ito, for the first time nag-integrate ka, i-integrate mo ito. So, yun na class yung EIY natin. So, this method nga is simply called the double integration method due to the fact class that the process is simply integrating the moment function twice. So, at least alam na natin kung bakit siya tinawag na double integration method. Kasi dalawang beses mong i-integrate yung moment function. And, tandaan nyo to class, no? Since dalawang beses kang mag-i-integrate, dalawa yung magiging arbitrary constant mo. For the first time na mag-integrate ka, magkakaroon dito ng C1 or the first arbitrary constant. And for the second time na mag-i-integrate ka, magkakaroon ulit dito ng C2. Okay, no? So, it has two constants. Okay, so sign convention muna tayo. The slope y prime or theta of the elastic curve is positive if the elastic curve rotates counterclockwise from the undeformed shape of the beam. Likewise, it is negative if the elastic curve rotates clockwise from the undeformed shape of the beam. So, paano yung ibig sabihin nun, class? So, illustration lang. Halimbawa, di ko kasi ma-drawing dito, no? Medyo pangit kasi ang magiging drawing ko dito sa PowerPoint slide. However, tiyagaan na lang natin, class, no? Huwag nyo na akong i-judge. Oops. Wait lang, ah. Ayan. Pen dapat. So, halimbawa, class, ito yung beam natin in an undeformed shape, ah. So, para ano lang, simply supported lang siya. So, tapos, i-sketch ko, class, yung kanyang elastic curve. Halimbawa, ito yung elastic curve natin simula dito, tapos dito. And maglagay lang ako, class, ng slope, no? So, kaya ayaw ko sa PowerPoint magsusulat eh. So, sige. So, ito yung dalawang slope natin. So, syempre, this is the slope of the line, no? So, ang mangyayari, considering this undeformed portion, class, dito sa kanan, class, umikot siya counterclockwise. So, this theta is positive. So, yun yung gusto kong i-point out. Kasi dito, sabi dito, kapag umikot siya counterclockwise pala, I'm sorry, no? From undeformed, ang pag-ikot niya counterclockwise, edi positive siya. And dito naman, class, sa kabila, umikot siya in a clockwise manner, no? Clockwise manner siya. So, this theta is negative. Diba? Kasi nga clockwise. Eh, in fact, kahit hindi mo naintindihin, class, itong rotation, no? Balik ka na lang sa analytic geometry, class, diba? Kapag ang slope, balikan natin yung analytic geometry natin, diba nga, ang slope natin doon is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Ang positive slope, class, is represented by this line. Tapos, ang negative slope, class, is represented by this line, diba? Sorry, wait lang. So, drawing ko lang yung negative slope, class, 'di ba? Pag ganito siya. So, this is for positive slope and this is for negative slope. And tingnan nyo naman, i-compare mo. So, di ba ito nagre-reflect sa positive slope according sa analytic geometry, and ito naman nagre-reflect sa negative slope according sa analytic geometry as well. So, yun, kahit analytic geometry na lang, class, ang tandaan nyo kung nalilito ka pa sa counterclockwise saka sa clockwise manner na yan. So, this is the sign convention for the slope, ah. However, for the sign convention of deflection, mas madali ito. Kapag yung pag-deflect, class, ay paangat, so the deflection is positive if the elastic curve moves upward from the undeformed shape of the beam. Likewise, it is negative if the elastic curve moves downward from the elastic curve. So, napaka-common sense nito, class. Halimbawa, ito yung beam natin. So, dalawang beam ang i-consider natin, no? Tapos, drawing natin yung elastic curve. Halimbawa, suddenly, ganito yung elastic curve nito. Tapos, ganito yung elastic curve sa kabila. So, of course, if the deflection, class, no, is upward, so therefore, this is a positive. So, napaka-common sense lang naman nun, class. However, dito, this deflection is negative kasi nga nasa baba. So, usually, class, the deflection of the beam is negative due to the fact na downward naman talaga yung load. However, class, no, there are some instances na nagpa-positive siya. So, pero rare ito. Mas common pa rin itong pababa. But again, as I said earlier, may chances na may pataas siya. Actually, may example akong prepare na may upward deflection. Okay? So, sige. Yun lang naman yung sign convention niya. So, next, before nga tayo mag-solve ng example, kailangan din natin class i-discuss kung ano yung boundary conditions. So as I said doon sa previous lesson natin, in differential equations, boundary conditions are set of points that used to determine the values of arbitrary constant Cn that appeared in the process of integration. So usually, if the differential equation is third order, so tatlo yon. Pero usually sa double integration method class, since dalawang beses ka nag-integrate, dalawa lang naman yung constants natin. And therefore, we need two boundary conditions. So, ganun lang yon. Kung ilan yung arbitrary constants, yun yung kailangan mo class na boundary condition. So, sabi dito, no, in the process of double integration method, two arbitrary constants will appear in the process, C1 in the first integration and C2 in the second integration. In order to get their values, establish the boundary conditions of the beam in their support. So, nasa suporta class ang key para mahanap natin yung mga boundary conditions class ng beam natin. So, dalawa lang class na boundary conditions ang kailangan mo. So, paano yon? So, sabi dito, the slope and deflection of the beam at the location of fixed support ay equal sa 0. So, kumbaga, the y prime is equal to 0 and the deflection is 0. Kasi nga, as I said, kung ito yung ating fixed beam class, di ba? Ayan siya, putulin natin. Tapos, drawing natin yung elastic curve. So, since support ito class, talagang ang deflection dyan magiging 0. Eh, kapag fixed support, tandaan nyo to, no? Kapag fixed support, talagang ang kanyang slope ay 0. So, yun yung tandaan nyo class sa mga fixed support. However, for the ano lang naman, simple support, kapag simple support, yung deflection lang class yung 0. So, halimbawa, drawing ulit tayo dito, putol lang. So, pag drawing natin yung elastic curve, so, yun lang. Dito sa mismong point na kung saan yung support, wala ka talaga dyan mahanap na deflection. So, yun. Yung delta natin is equal to 0 while yung theta is equal to 0 kapag fixed support. Pero kapag hinge or simple support, both hinge and roller, dapat ang deflection lang ay equal sa 0. So, tandaan nyo to class kasi ito yung magiging gabay nyo sa paglalagay ng boundary conditions. Okay? So, next tayo, of course, is the procedure for analysis. So, paano ba natin gagawin ang double integration method? So, sige, subukan natin na i-discuss yung mga steps. So, step 1, establish the moment function of the last segment of the beam. So, yun muna class ang una mong gagawin. Alamin mo kung ano yung moment function ng last segment. So, kung maalala nyo sa shear and moment function, meron tayong mga segment 1, segment 2, segment 3, until last segment. Tapos, for every segment, gumawa tayo ng equations. Ngayon, class, hindi na. Yung last segment lang talaga ang gagawan nyo ng moment function. Again, moment function lang to. So, next, integrate for the first time in order to get the first function. So, after nyong mahanap yung moment function, mag-integrate ka sa unang beses para mahanap mo nga yung slope function. And ito, no, binold ko pa, in-emphasize ko pa. Do not forget to place the arbitrary constant C1. So, of course, lalagyan mo yan ng C1. So, pangatlo, integrate for the second time in order to get the equation of the elastic curve. And yun na nga, do not forget to place the arbitrary constant C2. And that is for the second time na mag-i-integrate ka. So, mas maintindihan nyo ito kapag may examples na, di ba? However, i-discuss na natin siya dito sa video clip na ito. Pang-apat, determine the boundary conditions of the beam. So, usually, it is in the supports. So, the beam must have two pairs of boundary conditions because there are two arbitrary constants to be solved. So, yun na nga. Since dalawang constants, edi dalawang dalawang boundary conditions ang mangyayari. So, ganun lang yun. Panglima, solve for the values of arbitrary constant, then substitute them in the slope and elastic curve equation. So, yun lang naman. Ano lang yan? Usually, two equations to unknown lang naman yan, class. So, next tayo for number 6. In order to obtain the value of slope and deflection at any point of the beam, just substitute the corresponding value of x of the point. So, the value of x, diba, palagi naman na reference natin is its distance from the left end of the beam and to the slope and elastic curve equations or functions. Since nga ang madederive natin ay functions, f of x for the slope and deflection, so simply pag na-establish nyo yung equation, isubstitute nyo lang yung value ng x, then mahanap mo na yung slope, mahanap mo na yung deflection. So, ganun lang yung process natin dito, class, diba? So, pang-pito, ito yung medyo importante class kasi may mga questions na nagtatanong regarding sa maximum deflection, may mga pwedeng nasa ano siya, theory of structures, minsan nasa licensure examination, or minsan din class sa design. Kasi when we say in design, we have the serviceability requirements, no? So ano ba yung serviceability requirements? Meron lang tayong inaalaw na maximum deflection ng mga beams, di ba? So dito, for the simply supported beams class, the maximum deflection is located at the point where the slope is zero. So parang ang concept, 'di ba, nung maalala niyo sa shear and moment function, no, para mahanap niyo yung maximum moment, inequate niyo muna yung shear function equal to zero. Tapos hinanap niyo yung value ng x. And pag nahanap niyo na yung value of x, isa-substitute niyo yun sa moment function para mahanap niyo yung maximum moment. Exactly ganito din class sa sa deflection. Dapat daw yung slope is zero, then hahanapin mo yung value ng x, then isa-substitute nyo class yung value ng x sa function para mahanap yung maximum deflection. That is for simply supported. However, for cantilever beams, mas straightforward ito. If the applied load are downward, so usually naman talaga downward, then the maximum deflection happens at the free end of the beam. So, drawing ko lang siya dito, no? So, there is no need to equate the slope is to zero kasi sa case ng cantilever beam, kung ito yung elastic curve natin class, no? Ito siya, malamang ito yung maximum deflection class sa free end. This is the free end, di ba? So, sabi dito, the maximum deflection happens at the free end. There is no need to find for the value of x. Sigurado, nandito na yan, class. Okay? That is for cantilever, For simple beam with overhang, determine the maximum, no? Determine the maximum deflection between the supports by equating the slope function equal to zero and determine the deflection at each end of the overhang. Compare the results, then the deflection with higher absolute value is the maximum deflection of the beam. So ano naman yung ibig sabihin class nun? So halimbawa, may beam nga tayo dito, tapos may overhang siya. So pag pinahanap sa inyo class yung maximum deflection, so hindi siya masyadong straightforward. So pag drawing natin yung elastic curve, magiging ganito siya halimbawa. Hanapin nyo muna class yung maximum deflection sa gitna nitong dalawang support. Yun yung gustong sabihin yan. Hanapin nyo muna yung maximum deflection sa dalawang support, tapos hahanapin nyo yung deflection dito sa left end ng overhang kung meron man, then hahanapin nyo ulit yung maximum deflection sa right end ng overhang. So ganun class, ganun class yung gustong sabihin nito. So gusto ko lang kasi yun i-highlight, no? So wait lang. Nasaan yung highlighter natin? Tapos, wait lang So, nandito siya. Okay na yan for as long as readable siya, di ba? So, iyan, no? Basahin ko ulit. For simple beam with overhang, determine daw the maximum deflection between the supports. So, kung may dalawang support, para mahanap mo ito class, iseset mo muna daw yung slope equal to zero. Pero, kailangan mo pa rin mahanap yung deflection doon sa left overhang end and sa right overhang end. Kung sino sa kanilang dalawa din, kung sino sa kanilang tatlo, kasama na ito, yung mas malaki, so yung may malaking absolute value, yun yung maximum deflection. Okay? While sa cantilever, there is no choice sa free end agad. But sa simple beam, drawing ko na rin para fair, no? Sa simple beam naman class, ano lang, ito limbawa yung biga mo, usually magde-deflect yan ng paganito. So dito yung ating deflection max. The point of maximum deflection class is where the slope is zero. Okay, so ganun lang naman yun. So that is for simple beam. So for cantilever, overhang. So parang itong class ay free end. Parang itong may overhang pinag-combine lang na simple saka cantilever. Yung dito sa gitna ng span, analysis na simple, pero dito sa mga overhang pang cantilever. So yun lang, compare mo lang sila, sino yung mas malaki, yun na yung maximum deflection. So ganun yung gagawin nyo. So yun, okay na tayo, na-discuss na natin yung procedure for analysis. So to further understand nga the concept of double integration method, I prepare 6 examples class ba? Oo, 6. So this is example 1, so 4, 5, and 6. So, yun. Bago tayo mag non-prismatic beams. So, yun. So, i-end ko muna dito para nga ma-play nyo na yung video clip for example number 1. So, I hope nga, no, may naintindihan kayo dito sa ating video lecture. So, yun lang class, no? Bye-bye!